So next we have Kristina Kazdan, and I'm sorry, Kristina Collins, who works with David Kazdan at Case Western Reserve University. And you also work with John Gibbons and a number of other people as well. So
yes,
we have
Andy Monteiro is also here for this session.
Okay, so now we're going to hear from Kristina Kazdan and on the update to the
Kristina-
low cost. I'm sorry, I have too many windows open and I'm looking at too many things.
We're going to tell you about the low-cost version of the personal space weather station.
Take it away, Kristina. You're welcome.
All right, so this was, I'm glad that somebody brought up earlier the prospect of using one's existing ham station to collect data, because that's going to be one of the things that we focus on here. We're going to talk a little bit about the approach that we've been taking. David's going to give you a little tour of the data collection that he has set up. I'm going to talk about our plans for the future, and then John's going to tell us a little bit about his recent software contribution to FLDigi. So here we have our little cartoon illustration of how we use WWV, which is the time standard station for the United States, has very precise carriers on 2.5 megahertz, 5, 10, I want to say 15 and 25. And we use the fact that as the virtual height of the ionosphere between it and our station changes, that frequency shifts to make a proxy measurement of what the ionosphere is doing at that point. So, David, why don't you tell us a little bit about your station here?
The station that's doing the data collection now isn't anything special. This is a 30-year-old amateur radio transceiver, a Kenwood TS450. It is an old laptop repurposed as a Linux machine and not doing anything else. Old rig blaster. The antenna is similarly nothing special, just some wire going into the attic. Notice the frequency display on the dial, 4.999 megahertz. We're running this as a low IF system, so in that sense, it is an SDR radio. Slide. Yeah. The choice here, this is an old rig. They're available cheaply. It was among the first inexpensive rigs back in the day to use a direct digital synthesis chip. So it has frequency discipline from one point. As shipped, it was run with a quartz crystal. You don't need absolute accuracy for all of these measurements. You do need better than the quartz crystal, but it's easy to swap in a temperature compensated crystal. And actually, I put in a GPSDO, which has proved to have some interference on the signals that we want, but we will get that working. Slide. You'll see the computer. It's running FLDigi, which I will guess everyone here has seen. The graph that's being generated is 1 UTC day of Doppler shift. The Doppler shift here is the black line. It is filtered a bit. Kristina will talk about that more. The red line is received signal strength. This is 1 UTC day, so sun up here in Ohio is about the middle of the screen. That's the sharp drop in received signal strength. But you notice the Doppler shift precedes that. I think the data are accurate. This is a 2.5 megahertz. This is the night before last UTC. And as you can see, the night was rather hectic, more so than most. There was quite a bit of Doppler shift overnight.
All right,
and
now
we're going to talk about our collected data.
we will see if this video is able to play. If not, there is a link to the YouTube video. I recommend right-clicking it and looping it because it's only a couple of seconds, this animation. But if you can see what I see on my screen here, this is the collected stack of plots that David has taken since December of last year. You can see that that peak that happens just after sunrise in Cleveland, which is associated with the formation of the D layer, is sort of skating backwards as the day lengthens. This is the 5 megahertz data, which David, I believe, is being collected off of your wire in your attic. And the light blue line is unfiltered. The dark blue line is filtered. We have not tuned the filter very carefully, but you can extract some lines from it that at least look like something. So it's a promising start for being able to use this as a data collection method. And then I'm going to show you one more for 2.5 megahertz. And you can see the same thing here. This one is collected with a proper antenna. This is only about a week's worth of data for about Case's spring break. Because it's with a better antenna, requires less filtering. David, anything to add on this one before we move to the next event?
There was a question what the lines represent. That's local sunrise, Zenith, local sunset.
Yes.
The collection for 5 megahertz began at the winter solstice, so you can see the daylight separating. We're in Cleveland. Having daylight is really nice.
And something of a novelty. All right.
That is local to the receiver, correct?
Correct. That's local to the receiver. So everything is on the axis in UTC time. Once again, the left-hand side of the graph from our perspective here is the nighttime. And then during the daytime, you can see where there's all of that noise from the sun. All right, let us move on to talking about the software a bit. David?
The local software collects the data off FLDigi's analysis module, which John has rewritten in some important ways. We have some Python code locally that does some statistics checking, does some error correction for file corruptions, which we have found to be important, and prepares the graphs. I'm sure most listeners here are familiar with Linux's timing daemon crontab. The Python code then is called at the beginning of each UTC day as the previous day's file has just been prepared by John's modifications. Slide.
All right. So that particular set of software is what's being used for our prototype right now. It will definitely be undergoing more modification as we standardize this more to try to get people to participate. So I want to talk to you a little bit about this this adventure that we had in October when radio station WWV celebrated its centennial. And we had a big party out there, a big special event station. That first link, WWV 100, has information about that whole event. And a whole bunch of us went out there, had a lovely time. One of the things that we did as part of that celebration, partly to showcase the utility that WWV would have as a tool for data collection, was we did this thing called the Festival of Frequency Measurement, where we had radio operators across the country during that UTC day that was the centennial take Doppler shift data more or less in the way that we're describing. Some had GPSDOs, some did not. Some people were able to post 24 hours of data and a little bit more. Some people missed an hour here or there. And there was some variety, but for the most part, the data that we got, we were able to get into a usable state, and we're working on analysis of that concurrently. Here's a photo of WWV. If you ever find yourself in Fort Collins, definitely go out there. It's a beautiful place. Here's all of the participants. So we had something like 50 people across the country. This was a very interesting exercise. One of the things that we learned from having everybody use FLDigi was that there were some gaps in the way that FLDigi recorded things, which will now be rectified by John's code and hopefully make it so that instead of this being something that we would do for a one-day event and then have to spend a bunch of time manually cleaning up that data, we'll be able to automate it. So what this showed us above all things was that a lot of people are very interested in contributing to a project like this and collecting data in this way. And although it's important to ham radio operators that whatever we ask them to do for the sake of science doesn't interfere with their operating, they're very happy to let us have some downtime on their transceivers. So what we'd like to do is we'd like to build a system, which we've been calling the Frequency Analysis Network, to facilitate that as something that people could do. If I could leave my Radio Shack after I've been operating and set my radio and my computer to automatically record Doppler shift data that would then go into this database. This falls into the work that we've been doing for the low-cost personal space weather station, where we have specific hardware, but the same process that we're using to get data from our hardware, we can also be using for hams to upload their own data and thereby create a much larger general network at the same time. So this essentially, we've talked about a bit. And the data that I think we've seen from David's station, some of the other prototypes that we've been working on have been very promising, and we're looking forward to exploring that more. So I'd like to spend just a minute talking about fair data principles. For those people who have been going to the AGU meetings, I'm sure you've heard about this a lot, but since we've got a broad audience here and everybody's interested in citizen science, I think this is worth going over a little bit. So I think often when we think of scientific data collection, we think of this very linear process where you have something that you want to explore, and perhaps you have a volunteer effort, or you have some sensor system that you create, and you collect all of your data more or less all at once. Hopefully you collect all of the data that you need. Then you perform analysis on that data. Hopefully you perform the analysis correctly, and then you gain results which are hopefully interesting and which you then publish. And the fair data philosophy, which is about making sure that the data that you're collecting is maximally useful for future scientific work, adds in the notion of having a data repository. When we started collecting data for the Festival of Frequency Measurement, Dr. Frisell had everybody upload things to this repository called Zenodo. And at first I was like, that seems like overkill to give every data set its own DOI number and so forth for just a little one-day project like this. But then I realized DOI numbers are awesome. And having it so that every data set has one identifier that you can point back to is a very convenient thing. So when you switch over to putting data in this repository rather than having it be sent directly to you in order to analyze, it changes the way that your data collection process works. Your data collection now becomes this asynchronous thing. It may occur with you involved, it may occur without you there. And you as the researcher are then mainly retrieving your data from the repository in order to perform your analysis on it. And then after you've analyzed it, you can publish your results back to the repository. And everything has persistent indicators, so that if you collect a bunch of data and there's some indicator pointing to that data, some persistent identifier, you can then use the same identifier to see all of that data plus all the data that's been collected by the same person in the same way since. So you can think of this as there's sort of two buttons, one for collect data and one for analyze data. And ideally, you'd like to be able to push the collect data button, then push the analyze data button, gain some interesting results, go and get a cup of coffee for 5 years, come back and repeat the process and see what else you might be able to learn from the new information. So in that time, your data collection systems may change. You may get more volunteers. You may change some of your methodologies. And obviously, you're probably going to change elements of what you want to do in your analysis. But keeping that uniform is a really helpful thing in order to save yourself hassle and be able to access these things again. And I really like the tenets of the FAIR principles because they provide a really good rubric for ensuring that you'll be able to do that. So that's sort of the philosophy that all of this is meant to be based around. So if you yourself are interested in collecting Doppler shift data in this way,
5 minutes.
Yeah, okay. A good way to start is to take a look at the instructions that Aidan prepared and that others here prepared for the Festival of Frequency Measurement, which tells you where to go in FL Digi, how to set your radio up. And again, kudos to John on his addition. For those who are interested in joining the network, or more pressingly, for those who are interested in helping us implement automated data upload to Zenodo, there's a link here for the interest survey. I also put that in the chat at the beginning of this presentation. So please get in touch with us and let us know if that's something that you'd be interested in taking on, because we could use a little software help. So, all right, with that, I'm going to hand it over to John for talking a little bit about his additions to FL Digi.
Okay, I'm going to try and share the screen here. No, that didn't work. Let's try this again. Where are you? There. Are you seeing my screen yet?
Yes,
Yes.
we are.
Okay. Do I need to do that?
We're at 4 minutes.
Okay. Does that help expand the screen? Okay. When we started working with FLDigi analysis program, we found some basic flaws that were really causing us to have some serious problems. And the biggest one is when you restart the analysis problem, you lose all of your data. And for what we were doing, this was not acceptable. Also, our platform is going to be a Raspberry Pi, and the analysis directory is in a hidden folder, which for most common people who don't understand hidden folders in Linux is non-intuitive, so I had to fix that. The other problem is it sticks it into one big file and it doesn't separate it day by day, and using a cron tab job that we tried to utilize to create and do this process for us did not work out well. Also, there was no date stamp in the data, and there was no method for putting metadata in the header of the file. So in my modifications, the first thing I did is if the program stops, when it restarts, it picks up where it left off and keeps adding to the data that was already there. I have the ability now to include a date in the CSV file name of the collected data. It also includes the date in the first line of the code, and that's enabled as an option, which I'll get into in a minute for the version I released for FLDigi. It also allowed us to include metadata on the first line of this data in the file for each file that's created every day. I use absolute time only, and the relative time was moved, and on the change of date, it starts a new file with the new date. So now when you invoke the FLDigi package when it's released, there will be a status line at the bottom showing what's going on, and the frequency accuracy of the written data is to 3 decimal places now instead of 2. And the first thing I do under the Pi is I create a directory in your root user directory called capital FLD analysis, and that's where all the data is stored. And if you do nothing there, it acts just like the way the FLDigi's analysis package works now. And this is a screenshot of when you run the program. You can see the, where'd it go? There it is, the FLDigi analysis. This gets created in your username root directory. So when you run the program, it creates this analysis file, but it tags the date on the end of each day's data into the CS file, into the header, in the name of the file. So this is what's included in the file now. The first line is the standard header file that's there. Then you have the requisite information going on in there. Now, the cute thing that I added is if you go into the FLDigi analysis directory and you type in touchinfo.txt, which creates a info.txt file of 0 length, the program looks for that, and what happens is it adds, when it starts up every day, it adds the date as a metadata line before the header that normally appears for the data analysis. And if you go in and stick something in that info.txt file, like for example, I have my QTH, the frequency standard, and my latitude, longitude, altitude, if I put that in info.txt, when you run the program now, it sticks that whole line in the beginning of each day's data, so you can now have metadata associated with that. And I have submitted these to W1HKL, who's the author of FLDigi. He has accepted the changes, and they're already in beta testing even as we speak. But for HamSCI, I created something a little bit different. I do not create an FLD analysis directory. I created WWV data directory, and I look for 3 files in there: the org name, frequency standard, and lat, log, altitude text files. In each of these files, I contain information about the organization name, which for me was, as you can see here, it's pretty self-explanatory. Frequency standard, this shows what kind of frequency standard you're using in your radio. And then latitude, longitude, altitude is pretty self-explanatory. So when you run the program on the version that we're using for HamSCI, it sticks it in the root directory, and under the directory name www data, and you can see that the metadata file includes the date and then the 3 included files, and then the standard header file and the rest of the information. Now, if you do not include those 3 files, so I renamed so they weren't there and reran it again, it puts blank information into the metadata spots so we can spot that and know what's going on for the database down the road. And also, if it stopped and restarted, you can see here, I ran this for this morning till 4:20, and then I'm sorry?
Time.
Okay, this is my last slide. If you restart it, you see it restarts here, and then I restarted it again down here, so it just picks up where it left off and you don't lose your data. And in summary, it's coming to you when the next release of FLDigi comes out. Thank you very much.
Okay, thank you so much, John. Thank you, Kristina, and thank you, David. Very good. Those are all excellent updates. The data is looking very nice. I really like how you can see the dusk or the terminator move with the Doppler shift data, and it's great that we got those updates put into the FLDigi tree. Okay, we need to move along.